Hey guys, I just wanted to take a second and go over calculating percents with a video just to review the lesson that we did. For the most part, I just want to review really quickly that our decimal system is based on tens. When we move from the ones to the tens to the hundreds to the thousands as I'm moving left from the decimal and do my numbers, thousands, 10,000s, 100,000s, etc., we notice that we're actually increasing by a multiple of 10. Obviously, 1 times 10 is 10. 10 times 10, 100. 100 times 10, 1,000. 1,000 times 10, 10,000. So we have this multiple of 10, and we're simply moving our decimal one place over to make that number correspond with it. The example that I'm giving you now is I just doing some basic math that I think all of us are comfortable with. So when we're looking at this 12 times 10, we can all figure out 12 times 10 is 120. We count by tens 12 times, or we can recognize a simpler trick, which is when you multiply by 10, you're really just moving your numbers over into the next decimal column. So what you really did is you had a number 12 sitting here and a decimal was there, and all you did was when you multiplied by 10, you moved that decimal one place over, which in turn opened up a 0 there. That's where the 120 comes from. So we can actually figure this out by moving our decimal place as opposed to actually doing these multiplication techniques. So this way, when you get into like 1.2 times 10, well, again, 1.2 times 10, we're simply moving my decimal place, and as a result, I will end up with a number 12. 0.2 times 10, same logic. I'm moving that decimal place one place. So this one, I moved it one place to the right. This one, I moved it one place to the right, and I got a number 2. So this works again and again and again, and this last example was a tricky one. It's supposed to be 0.12, so we're getting quite small numbers. The only thing is this time I'm actually multiplying it by 100. Well, if we think about 100, that's 2 decimal places, that's 2 places away from my decimal, right? This is the ones, this is the tens, this is the hundreds. Well, if I have a number in my ones, the hundreds value right here is 2 spaces away from my decimal. So that would just mean I'd have to move this 2 spaces. So as a result, 0.12 becomes 12. So we can kind of figure out this movement as we go back and forth. This allows us to calculate percents really easy as well. So I'm just going to erase this stuff, and I just want to take a second and I want to show you guys this works exactly the opposite way as well. So if I had 12 divided by 10, so now I'm dividing, so now I'm simply going the opposite direction. Whereas in these examples, I was moving my decimal to the right. In this circumstance, I'm going to take that decimal, I'm going to move it to the left. So this becomes 1.2. If I had 1.2 divided by 10, same logic, decimal place, one place to the left. And I don't really have to do the math, I'm just following a pattern that I'm seeing. So one last example, if I'm dividing something by 100, let's say I had 1.2 and I divided it by 100. Now this is a little bit harder because all of a sudden I'm going to be moving that number, so 1.2 divided by 100, I'm going to be moving that decimal a little bit more. So I'm actually going to use a different color and show you. But what ends up happening is we said divide by 100. We said the 100 represents 2 units. So there's 1 unit to the left. Now the problem is I don't really have a space there. So if I'm moving 2 units, I have to assume a 0 is placed there. And as a result, my answer then becomes, my decimal point is here, 0 decimal, and it's 0.12 that is left as a part of my number. So that's the only part where things get tricky, is if I'm moving the decimal and I don't have values in that position, I just simply insert a 0. The same way I did in my times 12, I inserted a 0 here. When I did this multiplication, I went 12 times 10, my decimal was there, and I actually moved it one place here, and I inserted a 0. That's why that 0 went into go 120. So it's the same logic going the other way. The only difference is a 0 would go in front of the number instead of behind it. So I'm hoping that stuff makes sense, because if we know that, we can quickly make some calculations. I want to take a second and talk to you about percents. And we know that 50% means half. And the reason we know that is because 50 is half of 100%, right? 50% is half of 100%. And that's why we could probably quickly, easily calculate this and say, well, if 50% is half, then 50% of 60 means half of 60. So if that's the case, well, we can figure out that. So we can say that 50% of 60 then is going to be 30. So if I said I will give you 50% of my $60, that means I'm giving you half of that $60, which means I'm giving you $30. So hopefully that makes sense. And we kind of know that. I know that many of us have this intuitive understanding of what 50% is. Well, what happens if we move on to something else and we're looking at 25%? Well, if we're looking at 25%, I have to actually think about this and say 25% represents a quarter of 100, right? 25, 50, 75, 100. It goes in 4 times. So 25% is a quarter of 60. So what that means is I'm simply dividing my 60 by 4, right? So I can say 25% is a quarter of 60. So I'm going to actually say 25% is $15, because 60 divided by 4. And I'm dividing by 4 because it represents a quarter. I could also say I'm timesing by a quarter if that makes more sense. But either way, whether I times it by a quarter or I divide it by 4, I'm actually getting the same answer. Okay, because 60 times 1 is 60, and then I divide by 4 if I'm following my fraction rules. So 60 divided by 4 is 15, and I can in turn know that 25% is 15. So these ideas are there. 10%, this is where things actually get really easy, because 10%, same logic, 10% is a tenth, because I need 10% to get it to 100. So because of that, I'm simply going 60 divided by 10. And the reason I'm dividing by 10 is because that 10% is a tenth. So I'm taking a tenth of 60. Well, this goes back to those rules we were talking about before, and I can quickly and easily simply move my decimal back 1 unit, and I can say 60 divided by 10 is 6. And I don't need a calculator to do that. That's simply looking at a pattern. So now I know that 10% of 60 is 6. 1%, again, 1% is 100. I need 101% to get back to 100. I'd have to count 100 times. So really what I'm doing is I'm taking 60 and I'm dividing it by 100. Well, we looked at patterns for that, and we said all that means is my decimal place needs to move back. So it's moving 2 places back. So my decimal place moves there. So 60 divided by 100 is 0.6. And this pattern kind of continues. So I can use these basic ideas, this 10%, this 1%. I can even find 0.1%. Well, if 1% was 100 times, then 0.1% is 1,000 parts. Just moving the decimal 1 place over. So it keeps moving 1 step away from 100, right? So as we move to this, we get this thousands percent, or 1,000 parts. So same logic, I'm simply looking at 60 divided by 1,000. And 60 divided by 1,000, again, I'm going to have to move my decimal place to figure this out quickly. 1,000 would be 3 steps to the left, whereas 100 was 2. 1,000 is one more. So 3 steps, 1, 2, 3. And again, this time I have to insert that unknown factor because I didn't have a value 0 there. So I have to insert that, which in turn allows this answer to be 0.06. And I could add the extra 0 at the end. This 0 doesn't matter. I don't need it. But if I have it there, it's not impacting anything. But it's simply telling me my answer is going to be 0.06, right? I don't need to have that 0 there for it to be a correct answer. So now I know what I can quickly move to 10%, 1%, or 0.1%. I can easily now make calculations for 7%. Because if I find out what 1% is, well, I need 7 more percent. So I have to multiply that by 7. And now all of a sudden it moves it back up. So quickly and easily, I know 1% of 60 is 1/100th of 60. So I'm taking 60 and I'm dividing it by 100. And I got 0.6 because I moved my decimal place. And now I know I need 7 more of those. So now I know 7 times 0.6 will lead to 7%. And 7 times, I'm going to go like this and say 7 times 6 is 42. And I have 1 decimal place. So I get an answer of 4.2. Now, recognizing that we were dealing with money, I really want us to be dealing with money again. And I need you guys to recognize that this is actually 60 cents. So therefore, if that's 60 cents, that 0 has a value in money, and this 0 will have a value in money. Rather than saying it's 4.2 cents or dollars, we're going to actually say it's $4.20. Okay, so we can actually figure out how much money something is and quickly and easily make those conversions so that we can actually solve for values. It would also work if I had 7.4%. Well, if I know 7%, I can follow that same logic for finding my 7% by going 1% is 1/100th. So 60 divided by 100 is equal to 0.6. I know that's 1%. I could also find what 0.1% is. And 0.1% we know is 1/1000th. So 60 divided by 1,000 is equal to 6 cents. So this was 60 cents. I'll put the 0 back in here. That top one was 60 cents, and a 0.1% is 0.06%. So now all I have to do, and again, I'm just moving my decimals, all I have to do is say, well, how many 1% do I need to get to 7%? Well, I got to take this and times it by 7. So if I'm timesing 1% by 7, I have to times this value by 7. That's kind of what I'm doing, is I'm almost making this equivalent fraction. I'm just going to do it in a different color so it makes a little more sense. So I times this by 7 to get the 7%. So that means I'm going to times this by 7. Well, how many 0.1s do I need? I need 4 to get it there. So all I'm doing is now doing some simple math, right? I want to know the money. This is the part that I care about, was the money. So if I move this over, I can say, well, 0.6 times 7 we know is $4.20. We figured that out last time. 4 times 6 is 0.24. So this becomes 2 numbers behind the decimal, right? 2 numbers behind the decimal, 0.24. And I'm simply adding these together to get 7.4%. So it's $4.44, right? So we have this simple movement as we go back and forth. We're just simply bringing it down to a percent that's easy to find, like 10%, 1%, 0.1%. You could even find 0.01%, right? We'd just be dividing it by 10,000 if we were doing another decimal. So all I'm doing is making those movements and then moving it back up to the appropriate whole percentage. So in this case, 7% and 0.4%. So that's why I did those 2 different steps in here. So hopefully that makes sense to you guys. If you have questions, ask away.